Okay, so we're up and running. This recording. So this is a very brief run through how the labs are going to be assessed, what's involved in writing a report, how you plot a graph. Okay, so I'm hoping that at the end of this you'll have at least seen it once. I'll be there in the labs to help you out with some of the difficulties, and then when it comes to, with graph drawing in particular. And then after the lab, you might have plenty of questions about how to do the report. You know, I'll always respond to an email or stuff about that if you're struggling with that. By the way, I think in terms of the likely timetable for labs is that Group B1 will be in next week, and B3 will be in B2 will be in 2 weeks after that. So you're going to be on the even weeks. B1 will be on the 2, 6, and 10. Group B2 will be on weeks 4, 8, and 12. My maths is struggling. Hopefully that's right, but I'll get a more complete timetable out to you over the weekend. Okay. You won't have a lab anyway until if you're in B1, the likelihood is you'll have a lab with me next Thursday at this time. Okay, so good to see you. There's a few of you here. I'm just going to whittle on for a wee while. I'm going to share the screen first and show you a document that's on Moodle and is my sort of guide to labs and everything to do with labs. So just to show you, this is the document. It's on Moodle. You'll find it in the practical work section, and it is your Engineering Science Laboratory Workbook 2020. Okay. In here, you'll see a lot of advice on laboratory work, practical skills, report writing, how to write up some advice on writing up a report, how to draw graphs, how to use Excel. So anything I say will be recouped in that. I'm also recording this, so it will also be available through Moodle as well. You also here have all the experiments. You won't be doing all these experiments, but these are sort of descriptions of how you're to take the measurements and what you're to do in the experiments as we go through the different weeks of the semester. And then there's a few extra tutorial questions at the very end of the document. Right, so I'll keep on going, and just talk about some very basic rules. First thing to say, you've all had some experience of being in labs today, or being in the college at least today. It should be clear wearing a face mask is required unless you can't do so for medical reasons. When it comes to laboratories, you shouldn't be eating or drinking, particularly with your masks on, so anything like that should be done elsewhere. The physics labs are fairly, and C24 is not a dangerous place to be, but it is if people mess around. So the only real issues that happen in the lab is somebody being tripped by somebody else or something like that. So that happens very rarely, and it's about one of the things that will make me lose my temper. There's very few of those things, but that's one of them. So you don't want that to happen. One experiment involves the use of laser. I'll talk about that when you do that experiment, so we won't emphasize that now. I mentioned tripping. Bags and coats, leave them out of the way. Don't have them just lying on the floor next to where you're working, because somebody walking past could trip. Okay. When you're coming in, by the way, this booklet that I'm going through here, I've printed off a copy for everybody in every student in the class, and you'll be able to collect that when you're at the next lab. Okay, whenever you're in your next lab session, you'll be able to get the printed copy of this. So, and for later labs, always bring that workbook along with you, and also bring something with you that you can write down your measurements in. You're going to be taking measurements as any lab, and you need to record what you're doing. Okay. Write everything down in some form of booklet, or even a refill pad, something like that, but scraps of paper or loose sheets will be confiscated. And you know why they're going to be confiscated. Like I've made mistakes in my working career when I worked in industry of writing things down in scraps of paper, and you know exactly what happens to scraps of paper. They get lost, okay? So recording things correctly is a really important skill and discipline to learn, okay? So when you finish the lab, you should get a final answer. So when I see the final answer, I'm happy for you to go. So work on getting the final answer while you're in the lab. After each lab class, you'll have to do a piece of work. Generally, it'll be a lab report. And that's what I'm going to talk about in the next part of this presentation. Okay. And by the way, as well, with COVID as well, first of all, you should always tidy up your workspace when you're finished. But as part of the COVID sort of requirements, I'll need you to wipe down anything, your work area, anything you've touched. Okay. And we'll talk more about that when you're in the lab. It only takes a couple of minutes at the end when you're finishing off. Developing practical skills, you can read that for yourself when you get the report. So report writing, how is it going to be structured? Well, for this part, I'm going to stop sharing and I'm just going to talk you through the different elements of a report on my whiteboard here. Any questions? I'll just look, I'll just pause recording now and have a look at the different elements of what's required on a laptop. Sorry, what am I saying? What's required to write a report? I got completely confused there by something else is happening here. My computer's all gone all funny on me. So, right. Okay, so I'm turning this around. There's my whiteboard. So what do you need to put? A report has a definite structure. And I suppose one of the things I should say to you is, you know, you may think a report, you may never have come across a report before, or never written a report and think, what the hell do I do with that? What is a report? But you deal with reports all the time. You listen to reports on the news, you read reports from soccer or GA matches, or you listen to reports on what happened. There are very formal engineering reports, but reports come in all shapes and form. But one thing they all have in common is they are written in the past tense. So you should not, like the information I provide to you in the booklet gives you a set of instructions. Do this, do that. Do not copy that. That is not good practice in a report. You write what happened. You write in the past tense. This was done and that was done. Okay, I did this, then I did that. Right. So, yeah, got my markers here. So what do you put in a report? I'm going to emphasize that a report can be quite brief. Okay, it doesn't have to be hugely long, but it does have to include all the information you need to include. So the first thing you need is a title. What's the name of the experiment? That will be on the booklet, and so you don't have to think about that. 2, date and time. Really important as an engineer to write down the date and the time that you do any piece of work. Now remember, this is the date and time that you do the work, not when you submit it or hand it up to me. It's when you do it. There's a lot of important information is recorded just by dating and timing things. Okay, what's next? Well, you do an experiment to find something out. And the aim is a 1-sentence statement of what you're trying to find out. You're trying to find a value for something. It could be measuring the density. It could be measuring the expansion. It could be measuring the heat capacity. By the way, if you don't know what those terms are, you'll learn about them as we go through this semester. But it will be something you're trying to measure. So you just say, and the aim of this experiment is to measure the expansion, the specific capacity, the density, whatever. It's 1 sentence. Okay. All very short. Number 4 is the theory section. Now this can get very long-winded, but we're going to keep it simple. There's 2 things that I expect to see in the theory section. I want to see the equation. I've already said to you in class, every calculation in science and engineering is based on an equation. So in your lab, you're going to be doing calculations. So I want to see the equation that you're using. So put that in. And also, I want you to write down the definition of the thing. I mentioned things there like expansion, specific heat capacity, density. If you're measuring any of those things, give the definition of what each of those means. You probably don't know at the minute what any of those mean. So I'll tell you at the time, or look it up on Wikipedia or something like that, and get the definition. So definition is one sentence, and the equation is a line. Okay. So again, not the longest thing in the world. 5. A diagram. Couple of things you can do here for a diagram. You can take a photograph of the equipment. You can copy the diagram that's in your it's in the workbook that I give you. Remember, the workbook is online, so you can have the electronic version and copy that. Okay. Or you can hand draw something and scan it in. There are various different ways. Do not download a diagram from the internet, because it's generally not the same equipment that you use in the experiment, and that's not appropriate. You want the diagram to show what you were working with in the experiment. So we finally get onto something where you might have to write a bit of English. The method. This is what you did. And I said the word did. So it's past tense.
Did.
Okay. So you need to say, I weighed the block. I measured the length of the pole. I got the mass of the block of aluminium, whatever. It's past tense. Okay, so you just write down what you did. If you write your report as soon after the experiment as possible, you'll just remember it. You know, you'll remember what you did. So just write down the steps that you did. That's the quickest way to write a report, is to write the method as soon after you do the experiment as possible. You don't have to write, you have to have these in order in a report, but you don't have to write them in that order. You can put the method, write the method first when it's fresh in your memory. As part of an experiment, you'll be doing measurements, and you'll be getting data. So you should put the data into a data table. Okay, I'll talk a little bit about tables and explain that to you when you're in the lab with me. Okay, from the data, for a number of labs, not all of them, but for a number of labs, you'll have to draw a graph. Sugar. Okay, so for a number of graphs, number of experiments, you'll have to draw a graph, and I'll talk about how you do that in Excel in a moment. Yeah, and I want you to use Excel. I don't want you to hand draw the graph. As you become more proficient as engineers, you should be using sort of Word and Excel or other equivalents of the same packages, and using those. Okay, they're a great skill to have. The group, the other degree program, the BEng Honours in Mechanical Manufacturing Engineering, they go out on placement in year 3, and a big thing that they come back with is that Excel was important. They needed to know how to use Excel. So you don't know how to use Excel now. That's fine. You know, part of the process of your education is you learn these things. There's nothing to be afraid in it. Okay. Once you've got the graph, you normally you work out the result. You get your value. You say what the true value is, and you work out a percentage error. Now I will give you the true value, at the time of the experiment. And percentage error is a very simple calculation. We're going to do an example of that in a moment. And finally, the last part is the discussion. Okay, remember all that, by the way, for those of you that joined late, all that detail is in the booklet that you're going to get when you come to your first lab with me. So you don't need to be taking all this down, but I'm just highlighting the different points, the important points here. So I'm just going to turn around again. So for the discussion, I talked about the value you get in an experiment and the true value. You might think, oh yeah, I'm always going to get the true value. That's not the way it works. Every measurement that you take is inaccurate. Every measurement that you ever hear anybody talk about can never be 100% accurate. I don't know what the number of COVID cases yesterday was, but they may say that it's 402 or something. But you can bet that some of those were from the wrong day. Some of them came too late to be included one day and have been included another day. Somebody miscounted somewhere. There's all sorts of reasons why any number you hear isn't accurate. And that's true with any measurement. You can never be 100% sure. So, and as an engineer, if you have say you're part of a production system, and you're monitoring the output from a machine or something, and the output is perfect one day, and then it starts to drop, there's an issue there. And part of the role of an engineer is to identify what's causing that, to think through the whole process of how the system is working. And similarly, I want you to think through the experiment and try to come up with reasons why your answer is not equal to the true answer. Okay, it's not necessarily an easy thing to do. And I don't actually expect too much in the discussion. I want you to try, see if you can come up with things. Again, you'll get better at it as time goes on. Okay, so that's the different elements of a report. And what I want to do now is we're going to recap a few things. The first thing I want to recap is percentage error. So I'm going to share screen again. And I'm going to give you the equation for percentage error. There it is. Okay, at the bottom of the page. Hopefully you can all see that. So that's on page 3 in the booklet. And that's a nice little way of figuring out the percentage error is something you work out. And it's a way of showing how close your value is to the true value. If you've done the experiment really well and the equipment's very accurate, you'll get a small value for percentage error. If the experiment has had problems, you may have a large value for percentage error. Okay, so this is just a little measure to see how well everything's gone. Right, with that, I'm gonna put that equation up on the board, and then I'm going to give you a little problem to do, to work, just that you've worked out a percentage error. So I'm going to write that down. Here, I'll stop sharing now. Yeah, okay. So I'll turn this around, and the percentage error equals true value, sorry, your value minus true value, all divided by true value. And I've messed up, I've run out of space. Okay, I'll repeat it, multiplied by 100 equals. Okay, and that's how you work it out. You take the difference between the value you get and the true value, divide it by the true value, and multiply the whole thing by 100. So don't worry if you didn't get that down. I'm just gonna, well actually do copy that down. I don't know if I've left that up there long enough. Yeah, I'll leave it back. Could you copy that down? Because I want you to do a quick question for me, just so that you've got an example of working with this. Okay, percentage error is your value minus the true value divided by the true value multiplied by 100. And those are value. I know my V's and my U's look very, very similar, but that's value, not valve. Okay, so I'm just gonna share the screen. I'll leave that there while I'm sharing, looking at sharing the screen. Okay, so I have a little sample problem here for you. Very, very simple. You'll see here down at the bottom of the page, it's marked as 2. In an experiment, the value for the density of wood was determined to be 623.2 kilograms per meter cubed. Okay, so that was the measured value, your value. In a table, the student discovers the true value is 590. And that's the sort of difference you'd expect. You're going to get these differences. Determine the percentage error in this experiment. So I'm going to stop recording now. Okay, well, I can't actually stop recording while I'm screen sharing. So I'm going to stop screen share. Oh, I can. Let me see. No, I'm going to stop share. Sorry, I'll come back to that. I'm going to stop recording. Yeah, so we have from the question, the true value is 623, sorry, not the true value, the measured value is 623.2. The true value is 590. So it's 623.2 minus 590 divided by 590. All of that gets multiplied by 100. And hopefully, if you've done it correctly, you got a value of 5.6. Never put any more than one decimal place there. Do not write out a string of 18 numbers or whatever. Doesn't matter what it shows in your calculator or whatever. Just one number. It's not that important. It's not as important as your actual answer for the experiment. It's just a measure of how close to the true value you've been. Okay, that's I think what I need to do there. So that's the basics of report writing, what you need to include. If you have any questions on that when you're actually doing a report, you can always ask me. The next thing I need to deal with, or the main thing for the rest of this video or class, is how to graph this, how to put the results of an experiment on Excel. Now again, if I screen share with you once again, I'll go back to here. There's a little problem there, sample problems. A student, so these are some fake experimental values. Student carried out an experiment in an electrical circuit. You are going to do this experiment not as part of engineering science, but you'll definitely do it as part of an electrical module at some stage. She varied the voltage supply to the circuit and measured the resultant current. Voltage was measured in volts and current in milliamps. And the data obtained is shown below. Now, just to say, at your stage in your career in the college, you're in here 4 days. This is the end of your 4th day. Some of you will have maybe come across voltage and current before. Others will have no idea about the units. Don't worry about that. The important thing is we've got 2 sets of data. So whenever the student put the voltage to 6.1 volts, they got a current of 1.2 milliamps. Okay, and when they increased the voltage to 8.9, they got a current of 2.5. So this is the way we represent information in tables. Okay, so I'm going to stop the screen share on this, and I'm going to share now how we put that into Excel. So this is the same set of information in Excel, because in order to get an answer for the experiment, we actually have to draw a graph. And you'll find this keeps happening with a lot of your modules, but in particular in engineering science. Okay, so if you're new to Excel, what's going on here? Well, this is a spreadsheet. This is what a spreadsheet looks like. Each of these boxes is called a cell. Each cell has an address. You can see this one, D is highlighted there, 12 is highlighted to the left. So this is box number D12. It has an address, and that address is listed up here, or always appears up there. So what's the advantage of something like this? Well, one of the advantages is it can do calculations very simply. Now, 2 multiplied by 8 is not the hardest question in the world. But Excel can do this for us. However, if I press enter, nothing happens. I haven't told Excel to do a calculation. Okay, so just putting numbers in like that, 2 multiplied by 8, it will just leave it as 2 multiplied by 8. It thinks it's just text. In order to see that as a calculation, I must remember to type equals first. Now if I put 2 star 8, 16. And you're sort of saying, so what? I can do that in my head, and I could do it on the calculator. Hopefully you can do it in your head, and hopefully you can do it fairly quickly in your head. But 2 times 8 is 16 is very, very straightforward. You can make the calculations much, much quicker, much, much more complicated. It will do it very quickly. But there's a particular skill that Excel has with numbers that we'll come back to. And it is doing repetitive calculations, repeat calculations. If you ever find yourself doing the same calculation over and over and over again, Excel is the best place to do that. Okay, you'll see what I mean later on. Okay, so how do I draw a graph? I have my list of voltage values and my list of current values. I select only the values, not the headings up here. Okay, to draw a graph, I want to insert the graph onto my page. So I go insert. And then a graph is a type of chart. And so you've got a whole load of different possibilities here. So what are you going to pick? Well, okay, some confusion can arise. This is called a line chart. And that may look like what you want for a graph, but no, the one that has the axes on it, it's this one with the axes on it. And you'll see that's referred to as a scatter graph. Okay, so the technical name for the graphs are scatter graphs. So we select the downward arrow, and there's a number of options under scatter. For me, you never join the dots. Okay, so you only show the measured points. So we'll click there, and you can see the measured points on the graph. Now, one thing when you plot a graph, you should check that it's been plotted correctly. The way Excel works is whatever column is on the left-hand side, that data will be plotted on the horizontal, and whatever's on the right-hand side, that data will be plotted vertically. Okay, so that first, always check your first point, 6.1. I go across 6, okay, and I go up, and that's at about 1. So that's 6 across and 1 up. So that's fair enough. And then you look at the next one. That's about 9, and it's up about 2.5. So that's fair. Okay, we've worked it the right way around. Now, graph, that's not a great graph as it is there because it doesn't show me anything. All I can see is points. It doesn't tell me anything. I need to title the graph, and I need to label the axes as a first off. Now, how do I do all that? Well, there's 2 ways to access the functions. If I click into the chart, you'll see this plus appears up here. The other thing you'll see that appears, okay, under chart design, is over here, add chart element. So the plus and the add chart element are exactly the same. You can either find it under there, or you'll find the same list of things under there. For some reason, I prefer this one over here, but okay. The axes are already there. What I'm more interested in is the axes titles. I need to label the title, the axes. So I'll axis title, primary, horizontal, and I can just start typing. So the horizontal is voltage. in volts. Now you can see the text is up here. Okay. Hit enter and it miraculously appears down here. I then need to add the vertical axis. Okay, and now I can, the vertical axis, I don't like the writing going up along the side like that. You have to tilt your head to read it. So I'm going to look at more axis title options. I'm going to click on this. And this is something you don't have to do. This is a nice thing to know, but it's not essential. You'll see there's three different sort of icons here. Size and properties I'm going to click on. And I'm going to change the text direction so that it's horizontal. You'll see now that it changes to horizontal. And I can now start typing in that this is current in milliamps. Hit enter and it appears in that box. And everything resizes automatically. Finally, well, just for the look of things, I have chart title. I want to call this, it's whatever you want to call the graph. Generally something like it's close to whatever the title of the experiment is. This experiment is measuring something called Ohm's law. Again, you won't have heard of it. You may not have heard of it. Don't worry about it. But that's the general title of the experiment. So I'm going to hit enter and Ohm's law is now there. The other thing, the really important aspect of this is I see those points lying along a straight line. So I want to add in a straight line here. So I go again to add chart element. And the grid lines, by the way, so there's two things that say line there. There's grid lines and trend line. The grid lines you can see are already marked on the graph. The trend line is where I want to add in my line. And you might think, well, I just go for a linear, so that's a straight line, that'll work. But I can get more out of this if I go to more trend line options. Okay, if I go to more trend line options, you'll see on the right-hand side, this format trend line has appeared. Linear is there, which is great. You can see it fits the points pretty well. So I'm going to go to scroll down and display equation on chart. Okay, so and you can move that around just by clicking when you've got it's across. So I'm just going to put it there. So that's my graph done. You might say, oh, well, I could have done that myself and I could hand draw it. I don't think you could have hand drawn it as quickly as that or as accurately as that. And you definitely wouldn't work out the equation as quickly as that either. You might be saying, well, what's so great about the equation? How does that help? Well, I'm just going to stop sharing for a moment and just talk you through the importance of that equation on the whiteboard again. Okay, so always looking to try and get that screen on my laptop. Okay, right. So okay, so the equation of the straight line that we got on that graph was y equals 0.9009x minus 5. And it says, so what? Let's do my x a little bit better there. So what? Except you will have done at some stage, I hope most of you remember, y equals mx plus c. Now, what are these things? M stands for the slope of the line, and C is the intercept. So you saw the way the line worked. It was basically a line like that. The intercept is this point here. So that's about -5. And the slope of this line, if you compare, the slope is the number before the x. So whenever you see this written out in this time, that number before the x is the slope. So the slope of that line I now know is 0.9009. And why is that important? That's important because we normally use the slope to work out our answer. So once you have the slope, you can work out the answer in the experiment. That's, and how we do that is a little bit complex to explain, but I'll come back to it in the lab when we've got an example that we want to work out what the a value for something. So when I talked earlier about measuring density or measuring expansion or measuring specific heat capacity, it's a slope of a graph that you get, and from the slope of the graph, you get those values. Okay, so that was once going through all that, all right? And I'm going to go back to the thing. Something you may not have noticed is that this is not a good graph. Not a problem with the shape of it or anything like that there. It comes down to this thing here. And I go on about units. And of course you're not familiar with this yet, and you haven't done anything about amps or volts. But amp is the correct unit for current, not milliamps. In producing the equation of the straight line, we have done a calculation, and we have not used SI units. So I'm afraid I'm going to have to get rid of all that. I need to have current not in milliamps, but in amps. There's a couple of reasons for showing you this now. So I put current in amps, return. And okay, milliamps are thousandths of amps. They're a tiny fraction of an amp. Milli means thousandth. So I need to divide that number by 1,000 in order to convert it to an amp. So how do I get Excel to do a calculation? Hopefully you remember equals. Then I highlight that number. It's B3, that's the location of it. I use slash for divide, and I type in 1,000. And again, you'll say to me, well, I can do that on my calculator just as quickly. But the advantage of this is I now click on that box. You'll see that cross there is a big open white cross. If I go to the bottom right-hand corner of the box, it becomes a solid black cross. I click on that point and drag. And Excel automatically does the same repeated calculation for every other number here. Okay, so if you look up here, that's B3 divided by 1,000. Okay. Now, for the next cell, it's B4 divided by 1,000. And the next one is B5 divided by 1,000. So it is, by putting in this reference, B3, B4, it changes all the way down. So I've now got my current values. Right. So we're now going to redraw the graph. And I want you just to see how quick this is. You'll be a little bit slower, but with practice, you'll speed up. But it's I'm looking at the clock here on my PC. It currently says 17:00. Okay, I'll tell you what the time is when I've finished doing this graph. So we need to select the data. So that, but you'll see now if I go to select this one, I lose the other selection. If I do this, that's not going to work because we have an x-axis and a y-axis. You don't need 3 sets of data. So how do I do it? Well, the simple answer is you select that, then press the control key and hold it down, then select that. So I've selected 2 things of data. Okay, to do my graph, insert, in charts, it's the one that looks like a graph, only the dots. Okay, chart title. Sorry, I made a mistake there. Chart title, Ohm's law. Okay, chart design. Add different elements. So I'm going to go primary horizontal, voltage in volts, axis title primary vertical, and again, as we said before, I should have really gone access titles, more options. Click on that. Click over here, size and properties, the third icon, and text direction. This is only a little thing that I have a preference for. You don't have to do this. Current, and now it's in amps. Okay, and the last thing we have to do is add the trend line. So trend line, where do we go here? Remember, you skip all the options and you go to more trend line options. Linear is already selected, so you can see my straight line, but I really want the equation. Display equation on chart. And now the graph is done. Okay, it is 1702 now. It took me 2 minutes to do that graph. So if you're doing that by hand, it is much more complex than what we've seen there. Okay. Now, what I want to do now is how do you include that in a report? Well, I've just opened a Word file. Okay. So if I want this graph to go in my report, I click on the graph and copy it. Now you can either right click on it and you'll see copy, or my preference is to Control C. Hitting those two keys together will copy it. I'm going to stop sharing here and start sharing again, but just the Word document. And I'm going to, oh, we've got a very high, okay, Word document. I'm going to title this section graph. Control, now I want to paste. So I'd use the abbreviation Control V. Okay, I hope that works. Yeah, there you go. Click on the graph and center it on the page. Always nice to center it. Okay, that's the graph in. The other thing I need to do is the table, the information. So go back to, I need to stop share screen, back to Excel, share. Okay, I'm now going to select the entire table of data. I'm going to copy it, Control C, and I'm going to go stop share and go back. This is awkward, but anyway, hopefully you're following what I'm saying. Go into Word, share, and put in data, and do Control V again to paste it in. Okay, takes a bit of time. Now, that's a fairly disappointing looking, that looks as though it's been dumped out of Excel onto a page, and it does not look professional. But it's very easy to make that look professional using the tools in Word. So first thing off, you'll see if I hover on the table, can you see the little cross up the box with the cross in it on the top left-hand corner? Well, we're just going to go up there and select it. That selects the whole table. Then, because I've selected the whole table, up at the top of the page, there's table design and layout have appeared. So I'll go to table design. You get a whole load of options here, and you can go mad in whatever color scheme you want. I might just, for the sake of it, go to this one. Okay, and suddenly that looks an awful lot better. Another thing we can do when it's all selected is to center it on the page. So go to Home and center on the page. And the last thing that's bugging me is that the units are not on the same level as the titles. So I'd like to see them. There's no reason why we can't spread that out. So you'll see that if I move the cursor just to the separation between the two columns, you get kind of two arrows pulling either side. That will open out the column so it's wide enough for all its contents. Sorry, something went wrong there. What's going on here? Hold on. It's not working for me. This normally works. Oh, maybe that's the way to do it. Okay, there's another way. Oh, it really doesn't want to. Okay, not too bad the way it is. God, that's worked in every other class I've done that in, so I'm not sure why it's not working today. But anyway, can't get everything right. Okay, so just to remind you again, we're down on this, down in the graph. What's the slope of that graph? Remember, the slope y, the slope is the number before the x. So in this case, the slope is 0.0009. Okay, you then use that in another calculation to get your final answer. I'll explain all that in each individual lab. Don't have to worry about that for now. Okay, so I think that's the basics that I need to tell you at this stage. I'll just stop sharing. Just to remind you for the lab, when you're first in the lab, if you have a laptop and you're happy to bring it into college, it may be useful to have because there's no messing about with the sterilizing a workstation, the PCs that are there. If you don't have a laptop, come on in. There are PCs there and you can work on Excel and any of them. I'm just going to pause recording now because I think that's more or less everything.